While taking an evening stroll with the love of your life, or enjoying a lovely sunny day of football on a rather soggy playing field, or making a cute little snowman during the winter months, have you ever wondered what's below your feet? Ever wondered what's under this apparently smooth surface of Earth? Let's put it more precisely, what's inside it. In order to understand that, let me tell you some scientific evaluations about the structure of Earth. Dividing it on the basis of states leads to three major components of Earth's crust. Hard but smooth outer covering called mantle, a liquid component of Earth's crust called its outer core, which exists as liquid only because of the rising temperatures inside. Third one, again, a transition to solid state, its hot and compact inner core. Even though the temperature rises as we go deeper into Earth's core, so does the pressure. Consequently, in the inner core, the external pressure from the outer core and Earth's mantle is so severe that despite of all the heat, substance is transformed into a dense solid ball same as the size of Moon. In the liquid outer core, convection takes place, responsible for Earth's magnetic field as well as lava eruptions. That came new, right? Mainly the heat transfer from outer core results in heat transfer to the mantle, primarily composed of rocky materials. This transferred heat melts the rocks, producing magma, which indeed is too hot to handle. Now, some of you may argue that rocks don't melt. The answer to that argument is they do. It's just that it requires some severe heat. And the heat from your cooking range is certainly not adequate to melt them. What is a volcano? Which is the eruption temperature? What is hotter, sun or lava? Here's 8 things, and these are the 8 things about volcanoes. Names tend to tell you quite a lot about stuff. Similarly, the word volcano is derived from the word Vulcan, which stands in as the name of the god of fire in Roman mythology. As the name suggests, volcanoes certainly have a lot of fire in their bellies. Second thing that you should know about them is what they actually are. They primarily are hot lava, volcanic ash, and gases which escape from a magma chamber below the surface of Earth. These are the rocks melted by outer core, which leaves the Earth's mantle with a great heat and pressure, thus exhibiting the phenomenon of convection. Next question, where are they found? Volcanoes are most often found where tectonic plates are diverging or converging, and most are found underwater. The statement looks vague. Let me add some figures to it. 60% of all active volcanoes occur at the boundaries between tectonic plates. Most volcanoes are found along a belt called the Ring of Fire that encircles the Pacific Ocean. Some volcanoes, like those that form the Hawaiian Islands, occur in the interior of plates at areas called hotspots. So, grab a map and locate them. In the meantime, we move on to the next query. We know that they are hot since they are named after fire, but what's the exact degree of the severity of their heat? In the case of a Hawaiian volcano in one of those hotspots, the eruption temperature of freely flowing lava is about 1170 degrees Celsius, 2140 degrees Fahrenheit. The temperature of the lava in the tubes is about 1250 degrees Celsius, 2200 degrees Fahrenheit. Lava is indeed very hot, reaching temperatures of 2200 Fahrenheit or more. At its surface, called the Photosphere, the sun's temperature is a whopping 10,000 Fahrenheit. That's about 5 times hotter than the hottest lava on Earth. By the way, in the inner core of the Earth, the temperature does rise to 10,800 Fahrenheit, quite comparable to sun's temperature. Is the tallest volcano in our solar system on Earth? Actually, the tallest volcano in this solar system doesn't lie on Earth. Olympus Mons, as it's named, is actually well placed on Mars. It is a very large shelled volcano on planet Mars. The volcano has a height of over 21 kilometers, 21,000 meters as measured by the Mars Orbiter Laser Altimeter, short-named MOLA. Olympus Mons is about 2.5 times Mount Everest height above sea level. So if you want to visit it for holidays, just contact NASA. Second last key thing about volcanoes, are they always bad? Do they have some plus point? Even a dead clock shows the correct time twice a day. They should be good for something at least. Although volcanic eruptions pose considerable hazards to humans, past volcanic activity has done some good things too. Volcanic ash and weathered basalt produce some of the most fertile soil in the world, rich in nutrients such as iron, magnesium, potassium, calcium, and phosphorus. Volcanic activity is responsible for emplacing valuable mineral resources such as metal ore. They also give us geothermal power. Does volcanic activity, which we recently saw doing so many good things, impact climate change? This natural eruption does contribute significantly to climate change. During major explosive eruptions, huge amounts of volcanic gas, aerosol droplets, and ash are injected into the stratosphere. Injected ash falls rapidly from the stratosphere and has little impact on climate change. But volcanic gases like CO2 can cause global cooling, while volcanic carbon dioxide, a greenhouse gas, has the potential to promote global warming. With that, we approach the end of another informative video. Tell us in the comment section what you think about it. And in case our video didn't answer any of your confusions, feel free to use the comment section. Also, let us know what do you want to see in our next video. Take great care of yourselves. On that note, we sign off.